Hello. Hello and welcome to this video. In this video, we will solve question number 191 to 200 of permutations and combinations. So I'll say two things which I always say. First is that when I'm stating the problem, you should pause the video and try to solve the problem yourself. If you cannot solve the problem yourself, only then look at the solution. Never spend more than 15 minutes on a question, and if you cannot solve in 15 minutes, you can look at the solution, or otherwise you can skip the question and come back to it later. Never spend more than 15 minutes on a single question. So the link of the PDF will be in the description, and at the end I'll show you how you can download the PDF. So without further ado, let's get started. Question 191 says that how many different numbers of 7 digits can be found by using all the digits 1, 2, 3, 4, 3, 2, 1 so that odd digits always occupy odd places. So in a 7-digit number, there are 4 odd places. As you can see, the first place, the third place, fifth and seventh, as they are occupied by the odd digits. So we have 2 1s and 2 3s. Therefore, total number of occupying odd places would be 4 factorial by 2 factorial multiplied by 2 factorial, that is 6. For 3 even places, we have 1 4 and 2 2s. So the number of ways to fill these places will be 3 factorial divided by 2 factorial, that is 3. Therefore, total number of required numbers are 6 multiplied by 3, that is 18. Question 192 says that 10 different letters of an alphabet are given. Words having 5 letters are formed from these given letters. Find the number of words which have at least one letter repeated. So, if there are 10 letters and words have 5 of these, total number of words formed with repetition would be 10 to the power 5. Number of letters where none of the number of words where none of the letters are repeated, this should be words. None of the letters are repeated would be 10p5. Okay. Thus, number of words where at least one letter is repeated are 10 to the power 5 minus 10p5. Question 193 says that how many ternary sequences of length 9 are there which either begin with 210 or end with 210? So, ternary numbers, as you know, include 0, 1 and 2. First, we consider the case where required sequences begin with 210. So there are total 9, that means we have 6 vacant places which can be filled in 3 to the power 6, that is 729 ways. Similarly, number of sequences which end with 210 will be 729. However, there will be common sequences between these two which will start with 210 and end with 210. Number of such sequences would be 3 to the power 3 because 6 positions are filled. So remaining 3 can be filled in 3 to the power 3 ways. So that is 27. And therefore required number of numbers would be 729 plus 729 minus 27, that is 1431. Question 194 says that find the number of 7-digit numbers when the sum of those digits is even. A 7-digit number will be a number ranging from 1 million, let me see, 0, 10, 100, 1000, 10,000, 100,000, 1 million. Yeah, 1 million to 9,999,999. If units place is odd, then sum of remaining 6 digits must be odd. Or if units place is even, then sum of remaining 6 digits must be even to satisfy the condition given. Thus, half the number will satisfy the given condition. So the required number of ways to fill this is, this unit's position can be filled in 9 ways, 1 through 9. And remaining can be filled in 10 positions, but last one we have multiplied with 5 because there will be half the numbers. So total would be 45 multiplied by 10 to the power 5. Question 195 says that in how many ways 10 Indians, 5 Americans and 4 Britishers can be seated in a row so that all Indians sit together? So treating 10 Indians as one person, we have total of 10 persons. These can be seated in 10 factorial ways. However, 10 Indians can be seated among themselves in 10 factorial ways. Thus, total number of seating arrangements are 10 factorial multiplied by 10 factorial. Question 196 says that in how many ways can the letters of the word arrange be arranged so that A, the two R's are never together, B, the two A's are together, but no, not the two R's. Third is C is neither the two A's nor the two R's are together. So there are a total of 7 letters in a range, 2 of which are A and 2 of which are R. The total number of arrangements without no restriction would be 7 factorial divided by 2 factorial multiplied by 2 factorial, that is 1260. Now first case is when 2 R's are 1. We treat 2 R's are 1, so total number of such words would be 6 factorial by 2 factorial, that is 360. Number of words where R are never together would be 1260 minus 360, that is 900. Number of arrangements where two A's are together is 360 like previous case. But now we treat both A's and R's as 1 when both are together. Number of words would be 5 factorial. So that is 120. Thus required number of words would be 360 minus 120, that is 240. So the two A's are together but not the two R's. Okay. So that's why we considered this and subtracted it. And C is that neither the two A's nor the two R's are together. So from A and B, we find that the required number would be 900. That is this condition minus 240. That would be 660. Question 197 says that a man invites a party of M plus N friends to dinner and places M at a round table and N at another. Find the number of arranging the guests. So number of ways of dividing M plus N person into two groups such that one has M person and another has N person says M plus, this should be N, this is N, this is not 1. M plus NCM multiplied by NCN, that is M plus N factorial by M factorial multiplied by N factorial. Now, M persons can be seated around the round table in M minus 1 factorial ways. Similarly, N persons can be seated in M minus 1 factorial ways. So, total number of ways would be M plus N factorial multiplied by M minus 1 factorial multiplied by N minus 1 factorial divided by M factorial multiplied by N factorial. Now, we cancel out M minus 1 factorial with this, M will remain. And N minus 1 factorial with N factorial, N will remain. So, total number of ways will be M plus N factorial divided by Mn. Question 198 says that find the total number of signals that can be made by 5 flags of different colors when any number of them may be used. The signal can be made by using any number of flags. The required number of signals is we can make a signal with 1 flag, that would be 5p1. We can make signal with 2 flags, 5p2, and similarly 5p3 plus 5p4 plus 5p5, giving us a total of 325. Question 199 says that the letters of the word ought are written in all possible orders and these words are written out in a dictionary. Find the rank of tough in the dictionary. So the 5 letters in the word ought, which are all different, the alphabetical order of the letters are G, H, O, T, U. Now number of words beginning with G, H, O are 4 factorial multiplied by 3. Okay. So how did we arrive at this number 4 factorial by 3? That is the question. Okay. So if you look at this, it would be basically you select GHO are fixed. Okay. So if we fix GHO, we have 2 positions remaining here. Okay. So GHOTU. So let me think a bit. So number of words beginning with the GHO. Okay, I'll come back to it in a moment. Numbers of words beginning with TG are 3 factorial. Okay. And the same for TH. Number of words beginning with TOG, TOH are 2 factorial, that is 2. Tough is the first word beginning with TOU, just rank of the word tough is 24 multiplied by 3 plus 6 multiplied by 2 plus 2 multiplied by 2 plus 1. Okay, so now we come to this 4 factorial by 3 situation. So what happens is when the words begin with G, we can arrange the remaining 4 letters, 4 alphabets in 4 factorial ways. Similarly, when they begin with H, we can again arrange the 4 letters in 4 factorial ways. And same for O. So 4 factorial multiplied by 3 comes from there, that is 72. I was confused a bit. So now we have the ways of all possible beginning, and so tough is the first word beginning with TOU. So the rank would be 72, 24 multiplied by 3, 72 plus 6 multiplied by 2 plus 2 multiplied by 2 plus 1, that is 89. Question 200 says that the streets of a city are arranged like the lines of a chessboard. There are m streets running north and south and n east and west. Find the number of ways in which a man can travel from northwest to southeast corner going the shortest distance possible. So let the city be represented by a rectangle whose sides are of length A and B, north, south, and east, west, respectively. So this is shown here. So we have north, south, west, east, and P is here, Q is here. So this is northwest and this is southeast. So the man has to go from P to Q. For this, he has to travel A vertically downward and B horizontally eastward. So you have to come down A and go B. There are m minus 1 horizontal segments and n minus 1 vertical segments. Thus, from P to Q, there are m plus n minus 2 segments total. We have to choose m minus 1 and n minus 1 segments from these. This can be done in m plus n2 factorial by m minus 1 factorial multiplied by n minus 1 factorial ways. So that is what is our answer for this question. With this, we come to the end of questions up to 200. And in the next video, we will solve 10 more questions. So as I said in the beginning, I'll show you how you can download the PDF. So you can come to my website, www.astrology.org. You don't need to type www. Just type astrology.org. It will redirect to this website. And then you can download Algebra book from second link and trigonometry from the third link. You can go ahead and read those. There's a fair bit of warning that there can be a lot of typing mistakes because I don't have anyone to proofread this and I have not revised. The date shows the date on which it was updated, and the actual file will not have the date, because if I put date in there, then I will have to update all the YouTube links every time I change the date. That is not possible. So the actual files don't have date. Make sure that you rename your downloaded files with the date, and you can visit this probably weekly to see if the date has changed. If the date has changed, then that means there have been corrections or perhaps new questions have been added, and you can download the book again. So that is something you have to do. So if you spot any errors, for example, we saw an error. There are quite a few errors I saw. This n should be capital and this 1 should be n. So these kind of errors, if you find, this n should also be capital. This n should be capital. So there are quite a few typing mistakes. So let me know the errors in the comment, and I'll be grateful for you for pointing out the errors, and I will correct them as I identify or report. So I thank you for watching the video, and I hope that you have found this useful. So I'll meet you in the next video tomorrow with 10 more problems. Till then, keep practicing. Don't wait for the video. Go ahead and solve more problems. Go ahead and try to be ahead of the videos. And if you have doubts, you can watch the video or you can ask me in the comment box. So thank you for watching. Thank you for watching the video again, and I'll see you tomorrow in the next one. Till then, thank you.